Okay students, so now we can move for problem number 26. Okay, so in the problem number 26 you can see that they have given the letters of the word flower are taken four at a time and arranged in all possible ways. The number of arrangements which begin with F and end with R is. Okay, so this is the same problem as we have solved previously. Here you can just see that F has to be in the first place, R has to be in the last place. So F is in the first place and R is in the last place. Remaining four letter in the arranged remaining four letter in arranged in remaining two places in the form of 4p2, that is 12 ways. Okay, so therefore they are asking the number of arrangements which begin with F and end with R is. Okay, so the letters of the word flower, are taken four at a time, and arranged in all possible ways, the number of the arrangements where it begin with 4 and end with R. See here, F has to be in the first place fixed, R has to be in the second last place, that is fixed, and you have got two choices, so therefore that will be 4p2, so therefore it is going to be 12 ways. Clear? Very simple problem that you can understand. Now quickly we can move for problem number 27, that is A1, A2, A3 so on to AN are in n different letters arranged in all possible ways. The number of arrangements in which A2 follows A1 but not necessarily immediately. Okay, so very nice question. You can just see that the number of the arrangements will be n factorial by 2. That is directly straightforward. Okay, so because here you have got n different letters arranged in all possible ways, the number of the arrangements in which A2 follows A1 but not necessarily immediately. Okay, so therefore that will be n factorial by 2, that you can see it is directly from the results. Okay, now 28th problem, we can go for 28th problem, that is the number of four digit odd numbers that can be formed with this 10 digits. Okay, is 9 digits is. So here four options are already given. The number of four digit odd number, so odd number means you have four digits. In this place either you can write 1, either you can write 3, 5, 7, 9. That means it has got 5 choice. Okay, this can be written in 5 choice, and the remaining you can just see you have got 8p3. Okay, so these 5 numbers, that is 1, 3, 5, 7, 9 can be written in the last place. Remaining 3 blanks can be filled in 8p3 ways. Okay, so therefore that will be the total number of the 4 digit odd number is, see this has got 5 choice, that is 5 ways into 8p3, because this 3 places has to be filled and one is already used here, so therefore you can just see the remaining 8 numbers. Out of that 3 you have to use, because already here odd is fixed, because odd number is fixed here. So in the remaining 3 places you have to fill out of this 8. Okay, so 8p3 will be the right answer. Clear? Okay, so now we can move for the next question, so that you can just see option 2 will be the right answer before going to the next question. And now let us move to the problem number 29. The number of 5-digit numbers that can be formed with 0, 1, 2, 3, 4, 5, 6, 7, 8. That means here you have 9 digits where one is 0, and all of you know that in 5-digit number, this is 5-digit number, here I can't take 0. Okay, 0 I can't take here. So that's why the total number of 5 digits, the total 5-digit number is how much? You can just see that 9p5. So minus, in that you have to minus 4-digit number 9p4. Okay, so that you can just see 9p5 minus 8p4, because I can't use 0, so that's why it will be 8. Okay, so 9p5 minus 8p4 will be the right answer. 9p5 minus 8p4 will be the right answer. So this 8p4 will be the 4-digit number. 8p4 will be the 4-digit number. Okay, and 9p5 is the total numbers. The total numbers can be formed. The total numbers can be formed from 9 digits. Okay, so therefore 9p5 minus 8p4 will be the correct answer. 9p5 minus 8p4 will be the right answer. Clear? Okay, so now let us move to the 30th problem, that is the sum of digits in the units place of all 4-digit numbers formed by using the digits 3, 4, 5, 6, 7. Okay, so they are asking the sum of the digits in the units place. Okay, so for example, I will write this is 4-digit number, take this is 1. Okay, and I will write another 4-digit number. Okay, so now I have got two 4-digit numbers. Now what I have to do? This is the second number. Clear? So now I have to make sum of the units place. This and this. Okay, like this, total sum I have to find. So option 1 is 500, option 2 is 600, option 3 is 400, option 4 is 300. Now you can just see 4p3 into this is the sum of 4 digits, because I can take 3, 4, 5, 6, 7 can be in this last units digit. So 3 plus 4 plus 5 plus 6 plus 7. Okay, so this will be the sum of all these 5 digits, and with that you can just see I can arrange them in 4p3 ways. 4p3 ways. So therefore 600 will be the answer. Okay, so that means you have got 4 places. Okay, so out of 4 places I should choose 3 places, because the last 4th digit will be one of this. So that sum I have calculated here. So now 4p3 into 3 plus 4 plus 5 plus 6 plus 7 will be the right answer. So that is 600. Okay, so very beautiful question that you can understand it, no problem. And if you have any doubts, you can comment in the comment box. That is 4p3 into 3 plus 4 plus 5 plus 6 plus 7 will be the right answer. Now we can go for the number of 5-digit numbers that can be formed with 0, 1, 2, 3, 5, which are divisible by 5. Which are divisible by 5. It has to be divisible by 5 means the units place 5-digit number means 1, 2, 3, 4, 5. Here it has got two choice, 5 or 0. It has two choice, that is 5 or 0. So now the number of 5-digit numbers that can be formed with 0, 1, 2, 3, 5 which are divisible by 5 is, you have to find. Okay. So it has got two choice in the units place. So that can be arranged in two ways. So if I take 0 in the last place, so you have got 4 factorial ways of writing, that will be 24 numbers. And if I write 5 in the last place, again you have got 4 factorial minus 3 factorial, that is 24 minus 6 equal to 18. Okay. So therefore the total numbers, that is 24 plus 18, that is 42. Totally you can write 42 numbers. Okay. Because this 3 factorial is starting with 0. Because if I write 0 here, this will be only 4-digit number. It cannot be 5-digit number. So that's why that has to be subtracted. Okay. And 5 factorial, if the 5 is fixed here, you can take it as 4 factorials. And if 0 is fixed here, you can take 4 factorials. If I fix 5 here, total 4 factorial. In that, this 0, one of the case will be that the 0 will be in the first place. So that has to be subtracted, that is 3 factorial. So 4 factorial minus 3 factorial, that is nothing but 24 minus 6 is equal to 18. Okay. So 24 minus 6 is equal to 18 is the correct answer for the second case. So 24 plus 18, that is 42. So 42 will be the right answer for this particular problem. Okay. Now let us move for problem number 32. That is the number of 4-digit numbers that can be formed, with 0, 1, 2, 3, 5, 0, 1, 2, 3, 5, which are divisible by 2 or 5, okay. So you just see 0 is in the units place, which will be divisible by both 2 and 5. So that will be 4p3. Okay. You are going to get 24. If 0 is in the units place, then it is divisible by both 2 and 5. So therefore 4p3 will be the case 1. Next, if 2 is in the units place, it is divisible by 2. So 4p3 minus 3p2 you have to do. 4p3 minus 3p2. Okay. So that is 18. If 5 is in the units place, it is divisible by 5 in 4p3 minus 3p2. Again this is 18. Now total number of the cases will be 24 plus 18 plus 18, that is 60. So see here, you have 4-digit number. And you have got 5 choice. Okay. So either I write 0 here. If I write 0 here, it is divisible by 2 as well as 5, both. So therefore this has got 3 choice. So that will be 4p3, that is equal to 24. And next, for the 4-digit number, you just see, if I write 2 in the units place, again this has got 4p3 choice, but 0 cannot come here. So that's why you see it has got 2 choice here. So in that you have to subtract 3p2. So therefore 4p3 minus 3p2 will be the second case. On the same way, if I write 5 in the last place, again it has got 4p3. So 0 comes at the first place, that has to be subtracted, that will be 3p2. Okay. So now I have to add 24 plus 18 plus 18, that will be 60. So 60 is going to be the right answer for this particular problem. Okay. So that is option 2. Option 2 is going to be the correct answer. Now I will go for problem number 33. The number of 3-digit numbers of the form XYZ where X is greater than Y and Y is greater than Z. So that is any selections of 3 digits form or you can see any selection of 3 digits from 10 digits 0 to 9 given one number. If see here, if it is of 10 C3 ways, so totally you have 10 C3 ways to select 3 digits from 10, so that it will be 120. 10 C3 is nothing but 10 factorial divided by 3 factorial into 7 factorial. So that will be 7 factorial and 7 factorial is cancelled. 8 into 9 into 10. So 3 factorial, that means 1 into 2 into 3. Okay. 3 into 3, 2 into 5. So 8 into 3 is 24. 24 into 5 is 120. Okay. 5 into 4 is 20. 5 into 2 is 10. 10 plus 2 is 12. 120. Okay. So 120 is going to be the right answer for this particular problem. Okay. So I think this is a very simple problem because you have to select 3 from 10. So 10C3 will be the correct answer. Clear? Now we can move for the problem number 34, that is a 5-digit numbers divisible by 3 is to be formed using the digits 0, 1, 2, 3, 4, 5 without repetition. The total number of the ways this can be done is 5-digit numbers divisible by 3 is to be formed using the digits 0, 1, 2, 3, 4, 5 without repetition. Okay, so here you can just take, if a number is divisible by 3, its sum of digits must be divisible by 3. If it's a sum of the digits must be divisible by 3. So the selection of the digits from the given digits will be 0, 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. Okay. It can be arranged in 5 factorial minus 4 factorial plus 5 factorial. That is 5 factorial minus 4 factorial means this 4 factorial is starting with the numbers starting with 0. The numbers starting with 0. Okay. So now 5 factorial minus 4 factorial plus 5 factorial will be the right answer. So 96 plus 120, so total 216 is going to be the correct answer. Okay. So therefore 216 is going to be the right answer for this particular problem. Okay.